Assalamu alaikum students, this is Zishan again. In our previous video we did the theorem 15.1.1 and right now we are going to study 15.1.2, which is actually the converse of Pythagoras theorem 15.1.1. Let's study what the statement is saying. Statement is, if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right angle triangle. We are having a triangle A, B, C. What is given? In a triangle ACB, measurement BC is equal to A, measurement AC is equal to B, and measurement AB is equal to C, such that C square is equal to A square plus B square. Now, what was the condition in the statement? That one side of a triangle, you can see in a triangle, this CA is also represented by small b, BC by small a, and this BA by small c. What was the condition in the statement? That this once the square of one side of a triangle, we are picking this first side, the square of this will be equal to the sum of the squares of the other two sides. Other two sides are A and B, so C square is equal to A square plus B square. This is the part of given. Now what we have to prove? We have to prove that triangle ACB is a right angle triangle. This statement was telling us then the triangle is right angle triangle, so we need to prove that triangle ACB is a right angle triangle. Now what is the construction? Draw CD perpendicular to BC. This is the CD that we have to draw. We are drawing this CD perpendicular to this BC, but such that with the condition that CD is congruent to CA. This CD is congruent to CA, and now join the points B and D. So we join B to D. Okay, now we are moving to it. And in the proof, step 1 is to study triangle DCB. If we look in the diagram, the triangle DCB, this triangle is a right angle triangle. As in the construction we have drawn this CD perpendicular to BC. Perpendicular means this angle is of 90 degrees, so triangle DCB is a right angle triangle. In any of the right angle triangle which we studied in the theorem 15.1.1, Pythagoras equality is applicable. So what the Pythagoras equality was, that the square of the hypotenuse is equal to the sum of the square of the other two sides. If this is the right angle triangle, BD will be hypotenuse, so square of this BD is equal to the remaining two sides are A and B, so BD square is equal to A square plus B square, and the reason is just I told you, Pythagoras theorem. But in the given, we were also given A square plus B square is equal to C. So from these two equations, both equation, if A square plus B square is equal to BD square, and this A square plus B square is also equal to C square, then BD square will be equal to C square. From these two equations we are having this equality, and further on taking the square root, we will have BD is equal to C. This was the step 1. Now in the step 2, we are going to study two triangles DCB, which is this one DCB, and the second one is ACB, which is this ACB. First of all, CD is congruent to CA. This is CD and this is CA. Both are congruent. Yes, we have told in the construction that CD is congruent to CA. Next one is BC is congruent to BC. The side BC is common in both triangles, so BC is congruent to itself BC. And the third one is DB is congruent to AB. This is DB is congruent to AB. AB is also represented by C, and over here in the step 1 we have proved that BC is equal to C. So these both are equal to C. The reason is each side is equal to C, so we can have DB is congruent to AB. Okay, now from side postulate, we can have the congruency of both these triangles. So we can have triangle DCB is congruent to triangle ACB. Now if any of the two triangles are congruent, any of their corresponding angles will also be congruent. So we are taking angle DCB. This is angle DCB, means this angle. This is the angle, and is congruent to angle ACB. ACB means this is the angle. So these both will be congruent because of the congruency of both triangles. But in the construction, we said that this angle C is of 90 degree, and if this angle DCB means this angle is congruent to ACB means this angle, and the second thing is this angle is of 90 degree, then this also will be of 90 degree. So we have proved that angle ACB is equal to 90 degree, and if this angle C is 90 degree, then the triangle ACB is a right angle triangle, and this thing was to be proved. Okay students, we do question number 5 from exercise 15. In a quadrilateral ABCD, the diagonals AC and BD are perpendicular to each other. Here, we are having a quadrilateral A, B, C, D, and this AC and this BD. These two are diagonals which are perpendicular to each other. What we have to prove is, in this equation, in this question, is AB square plus CD square is equal to AD square plus BC square. This equality we need to prove. If we look at this triangle AOD, this AD is behaving as hypotenuse. So according to the equality of Pythagoras theorem, it will be AD square is equal to the sum of the squares of the remaining two sides, and remaining two sides are AO and DO. So equality will be AD square is equal to AO square plus DO square. This is equation 2. Similarly, if we look at the triangle AOB, this AB is behaving now as hypotenuse. So this square will be this square plus this square. So we are having equation AB square is equal to AO square plus BO square. Again, by applying the equality of Pythagoras theorem, this we call it equation 2. In triangle BOC, this BC is behaving as hypotenuse, and equation will be BC square is equal to CO square plus BO square. This is CO, this is BO. So this is equation 3. And looking at this triangle COD, this is again a right triangle, and CD is behaving as a hypotenuse. So CD square is equal to OC square, C square plus DO square, like this. CD square is equal to CO square plus DO square. This is equation 4. If we look at this equality that we need to prove, the left side of this equality is the sum of AB square and CD square. So AB square is the left side of equation 2 and CD square is the left side of equation 4. So we need to add both equations, equation 2 and equation 4. Upon adding these two equations, we have AB square plus CD square on the left hand side, and we have to add their right sides as well. So AO square, this is AO square plus BO square is equal to CO square plus DO square. And if we look at the right side of this equality, AD square plus BC square we are having. So AD square is the left side of equation 1 and BC square is the left side of equation 3. So we are adding equation 1 and equation 3. On the left side we will have AD square plus BC square is equal to, this is AO square plus DO square, this is AO square plus DO square plus CO square plus BO square. This is, we named those equations equation 5 and equation 6. And if we observe both equations, right side of both equations are same. You can see AO square, AO square plus BO square plus BO square plus CO square plus CO square plus DO square plus DO square. So both equations are having equal right hand sides. That means their left hand sides will be same. Comparing equation 5 and 6, we can have AB square plus CD square is equal to AD square plus BC square. That means the left sides of both equations 5 and 6 are now equal, and this equality was to be proved.